So we are picking up 9 squares and varying things around and looking at quite a few possibilities. So the very first task is making use of 9 unit squares, that is a space that has the area of 9 square unit. Make as many rectangle as you can whose length and width are a whole number of unit. So this statement, for now you guys ignore this. So let's figure out how many rectangles can we make. So what we have on our hand is a space wherein we have 9 such squares. Can you see this? 3 plus 3 plus 3, 9. Okay, so we have 9 squares in this manner. We have to make as many rectangles as possible. So one possibility is this itself, right? This is one possibility. This is one possibility. So possibility number 1. Next, what else is possible? Let's try. So I'm trying to make a rectangle. This is not possible because we are missing one. So let's try to rearrange again. This is also a rectangle. Technically, this is a square, but square is a specific form of rectangle, so it's okay. So this is your possibility number 2. This was possibility number 1. Number 1. In both the cases, my question to you guys is, what is the area? What is the area? Yes, it is 9 square unit. Why? Because we are using 9 squares. That's it. 9 square units. So 9 square units. Right? Because we are using the same thing again and again. So number of unit squares is 9. So all of this is of 1 square unit dimension. So how many are there? There are 9 of them. I'm playing around with them. So there has to be 9. I'm not deleting any over here. I'm making use of 9 and rearranging them. So the area has to be the same. You guys agree? Okay, that's one observation. So I have few more questions that will push you guys to the next observation. Which rectangle has the greatest perimeter? Again, technically both are rectangles. So we can figure out the perimeter. Perimeter is to do with the sum of length of the sides. So this is 9, this is 1, this is 9 again, and this is 1. 9 plus 1 plus 9 plus 1, this is 20 units. So perimeter over here is, this is 3, 3, 3 and 3. 4 3s are 12. 12 units. So which is the largest? Which rectangle has the largest perimeter? Answer to A is possibility number 1 is the largest. Which is the least? Other one is the least. Possibility number 2. Agree? Now, next question is, next task is actually, the task is done. Make a figure with a perimeter of 18 units. Again, the question here is to make use of all of this, not to miss anything, not to exclude anything, and we should get a perimeter of 18. So actually, let's see if the perimeter is 18 over here. So we can clearly see that we can get different perimeters. So is this 18? Let's have a look. I just put this randomly. 1, 2, 3, 4, 5. Okay. This is 2. This is 4. And this is 1, 2, 3. Actually, this is kind of plus 3. You know, this, then this put together. So does it give us 10 and 14? No, this does not give us 18. So how will we get 18? Well, let's look at this. This is our starting point. We already have 20 over here. 20 we can convert it to 18. So let's go back to 20 actually. Let me go back to the original structure. So this is 20. The perimeter over here is 20. We have to make 18. So let's try doing that. So how can I make 18? If I do this, will that make 18? Maybe this and this. Again, I'm doing some mix and match over here. Let's see if I'm getting 18. So we have 1, 2, 3, 4, 5. Oh, sorry. Actually, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. No, this is 20. I want 18 though. What to do? See, the funda here is, now let me teach the funda. Doing randomly, end of it, some point of time, we will achieve the goal. But we can't sit and do randomly. We have to be smart about it. See, we have 20 now. The perimeter is 20. Perimeter has to do with the lengths, this set of lengths, right? Those are your perimeters, the outer boundary per se. It can be any structure, like even this. So basically, we have to somehow reduce it. By doing this, I ended up just having the same, right? But here, by rearranging in this manner, by closing them up, it is reducing. You guys agree? So I have to close them up. Let me close two things. Let's have a look. Maybe this and this. Let's check if this helps. So clearly this is not helping. Let me not have that. This is 20 units. Let's have a look at this now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We achieved it. 18 units. How did I achieve this? By getting the squares closer. But why does that help? Why is this getting closer thing helps? Well, by getting things closer, we are closing up the boundaries. By getting things closer in this way, I'm closing up the boundaries. Now, more boundaries is open to the surrounding. If we get things closer and closer, right, in this manner, the boundary reduces, right? The exposure reduces. Okay. So for example, over here, the exposure has reduced. Right? So let me actually take this example. And show it to you guys. Okay. Let me do it here itself. I have a lot of text over there. So here guys, when I tell exposure, I mean this. All of this is the exposure. All of this is the exposure. Right? So when I rearranged, see this side which were exposed initially, and even this, to be honest, even this was exposed. All of this were exposed. But by doing this, what happened? This went inside. This space went inside. Okay. So those space went inside. So that's how you reduce the exposure. By how much space went inside? 2 unit. So from 20 minus 2 will give me 18. That's what happened over here. Did you guys get that? So we had an exposure of 20 outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, because of rearrangement, those things went inside. It is sharing boundaries between other squares. So by doing so, what happened? The edge exposed to the outside space, it reduced. Okay, so one more best example is this 3 by 3 square, right? So you can see that all of this space is closed within the close to the external world. But here there's a clear cut exposure. And that's how you can reduce the value, right? So this is one possibility. There are many possibilities, but this is one of them. Can you make other figures for each of the above 3 perimeters? Or if there are only one shape within that perimeter? What is your reasoning? Okay. So this is shape number 1. I was able to make another shape with the same amount of perimeter. Right? This is one possibility. So can you make other shaped figures for each of the above 3 perimeters? So what did we get? 3, 18 we have. We have 20 and we have 12 also. Okay. So 20 we were able to get. So when it comes to 20 units of perimeter, we are able to get many structures. That's the first possibility. Next, when it comes to 18. So 18, what do you guys think? So 18 was something like this. I can aramse move this way, and you have one more structure. This 2 will be 18, right? Because the same sides are closing the figure structure. So you'll end up with 18. So 18 2 is possible. So this was 1, and even that second one too. 18 units of perimeter. We are able to get many structures. Now finally we have 12. So let's see 12 can we achieve any other way. 12 can we achieve any other way? Let's have a look. So this is 12. So if I open up and keep something over here, what happens? Remember, whatever sites were enclosed, those are getting exposed now. So by default, by chance, if you open up anything, what will happen? The perimeter will increase. So no, answer is no for this. When it comes to 12 units of perimeter, will not be able to achieve with any other possibility. Why so? But it's quite commonsensical actually. I know all of this is complicated for you guys now, but yeah, you just take a second and think about it. You draw and think about it. That's how you can make it easy. Or take a day, come back to this, then you'll understand this. If I break the structure and rearrange them, by default, you're exposing more sides. And so the perimeter will increase. So by breaking the structure, and on rearranging, you have to rearrange. We will end up increasing the perimeter. Again, guys, these are not easy concepts. These are quite hard for a 6th grader. So if you're finding it difficult, it's okay. It is difficult. So you need a bit of patience. You need to try yourself, think over. That's how you'll be able to make it easy. So from all of this, whatever we studied till now, so we started off with taking 9 square units, arranging them in rectangle shape. We got two possibilities. Area will remain the same. In all of these cases, what happens? Did the area change? No, we are playing around with the same 9 squares. But the perimeter, we are able to achieve different value, 20, 12, 18, right? So we are able to achieve different value. That's what we are able to conclude over here. Some cases, yeah, we can't cross a certain value, right? 20, we can't cross 20. And we can have, but we can have different structure. Well, 12, we can't have different structure, and we can't reduce lesser than 12 because that's the least amount of boundaries that you can enclose, height. So the conclusion will be what? The conclusion is for a fixed area, the perimeter is not fixed. The shape of the figure can be changed while its area stays the same, which in turn changes the perimeter. So this is the conclusion. Right? I hope you guys were able to see with this as well. And to put it across one last time, we started off with 9 squares. And we will be able to rearrange in this manner, or maximum this possibility is also there, and nothing else. In all of these three cases, the area did remain the same. Remember, the area did remain the same, but the perimeter, it can change. Right? All of this exercise, it just led to that point. Everything else, it might be too much for you guys. That's okay. That we'll learn slowly. But I hope you guys were able to understand that area can remain the same while the perimeter can change. That's something that you guys should take in.